So I'm making and or made this video to show whoever's watching it how to solve inequalities. And an inequality is basically just an equation, only instead of having x actually equal something, it would be less than or greater than or less than or equal to or greater than or equal to. And in this case, it's greater than or equal to. So what you want, like what you're trying to do is get x alone. So I have 4 examples to just show you how you might solve different ones. So the first one is 7 minus 3x is greater than or equal to 22. So because you're trying to get x alone, you want to get rid of 3 and 7 and make this answer whatever it's going to be. So I'm going to start by getting rid of 7 because it's easier than getting rid of 3. So if you're trying to make 7 0, then you'd want to subtract 7 because 7 minus 7 is 0. So you would do that, and it cancels itself out. But so you're not just taking away random numbers, you have to also do the same thing to 22. Now you're trying to get rid of negative 3. So because it's being multiplied by x, you wouldn't just subtract it, you would divide it. So the answer would be negative 5. X is greater than or equal to negative 5. But when you multiply or divide this answer by a negative number, the sign switches. So instead it would be x is less than or equal to negative 5. So the last thing you have to do when you finish the problem is check it to make sure you're not going crazy or anything. You're probably not. But anyway, find a number that could be in the answer. So in this case, if it's x is less than or equal to negative 5, it would have to be either negative 5 or anything deeper into the negatives. So we could do negative 10, for example. And then you would redo the problem kind of like this. Oh, I'm going over the red line. Whatever. You would do this problem now. 7 minus 3 times negative 10, is greater than or equal to 22. And you would just do that, 3 times negative 10 is negative 30, and then 7, it would be 7 minus negative 30, but since it would be, 7, negative 30 minus 7 would be negative 37, but 2 negatives here equal a positive, so plus sign now. It would be 7 plus 30, which is 37. So 37 is greater than 22. It's not equal to, but it could be equal to, depending on what number you choose, which means it's correct. Big check mark. So the next problem here is 6x minus 5 is less than negative 17. So I started with the first number before, but this time, once again, I'm just going to do the easiest number, which would be making negative 5 0. So in order to do that, you would just add 5, the opposite of if it was a positive number, because negative 5 plus 5 is 0. So you would do that, plus 5, and then do that to here, to negative 17, and make it 6 times x is less than negative 12 this time. Yeah. So now I'm trying to get rid of 6. So, likewise to this problem, you would just divide 6 by 6, and then divide negative 12 by 6, which would get us, and you don't have to switch the sign this time because you're not dividing or multiplying by a negative number. It would be x is less than negative 2. Because if it's an odd number of negative signs that you're multiplying with the multiplying numbers, then it would be a negative, and if there's an even number, it would be a positive. So that's our answer. Now, once again, we have to check it. Anything less than negative 2, so we could do negative 4. 6 times negative 4 minus 5 is less than negative 17. So 6 times negative 4 is negative 24. Negative 24. And then minus 5 would be negative 29. And 17. And negative 29 is less than negative 17. So that's also correct. Yay! With this fraction type looking equation, it's really just dividing x being divided by negative 5. Like x divided by negative 5. So you would just multiply it by negative 5. That cancels itself out. And then 3 times negative 5 would be negative 15. You would switch the signs. So it would be x is less than negative 15. Yeah, check your, and here you would do anything less, again, anything less than negative 15. So how about negative 20? Negative 20 divided by negative 5, since there's an even amount of negative signs, it would be simply 20 divided by 5, which is 4. So 4 is greater than 3, so it works. I don't think I have enough ink for a good check mark, but still, I tried. So this next problem is basically just like the previous one, only there's an extra step to it. So the problem is 2x over 7 is greater than negative 4. So, like the other one, you would start with the division part, or at least that's how I would start it. So we would multiply it by 7, which would cancel itself out, and then you multiply, oh, probably can't see that, but that's 7, negative 4 by 7. So it would then be 2 times x is greater than negative 28. I hope you can see that. So the extra step is like the ones we've done earlier, which is getting rid of the 2 by dividing it. And then you would divide 28 by 2, which would get us to x is greater than negative 14. So it can be anything greater than negative 14. So to check, we can use any number. So I'm going to use 7 again. So 2 times 7 is, divided by 7, is greater than negative 4. So you would, I'm just going to do it like 2 times 7 is 14. That's 14. And 14 divided by 7 is 2. So 2 is greater than negative 4. So this is good. So yeah, I hope that gave you a little, picture of how to do inequalities. So yeah, alright. Bye.